finish station 2 in this video. In this problem, there are no like terms to collect on the left side, no like terms on the right side. So we can go ahead and start moving the variables to one side and the constants to the other side. I'm going to move the constants to the left side, the variables to the right side. I'm going to start by moving this positive 18.24, which is a constant, to the left side. To do that, you need to use inverse operations. On the right side, 18.24 minus 18.24 equals 0, so we're left with negative 5.9x. On the left side, we carry down the 3.5x, and then we take 0.8 and we subtract 18.24, and we get negative 17.44. Now I'm going to move the variable that is on the constant side over to the right side using inverse operations. Whatever you do to one side, you need to do to the other. On the left side, 3.5x minus 3.5x is equal to 0, so we're left with 17.44. On the right side, negative 5.9 minus 3.5 gives you negative 9.4x. Negative 9.4 is being multiplied by the x. The inverse operation is division. So to get rid of that negative 9.4, you divide by it. And we're left over here with just x, because negative 9.4 divided by negative 9.4 equals 1. So 1x we can just write as x. Then we take negative 17.44 and we divide it by negative 9.4. And we get 1.855. And I'm going to round it to the nearest thousands place. So tenths, hundredths, thousands. So 1.855. And that's not what it equals exactly. It's approximately, since we rounded. Number 4. First, you look for like terms on the left side. There aren't any. Look for like terms on the right side. There are not any. So we're going to move the variables to one side, and we're going to move the constants to the other. So I'm going to move the constants to the right side and the variables to the left side. I'm going to start by moving this positive 0.52x from the constant side over to the variable side using inverse operations. Now, be careful with your decimals. I saw a lot of people in their working class forgetting that there's a decimal there. So the trick is to just make it large enough so that you see it and you don't make a mistake. On the right side, 0.52x minus 0.52x, we're left with 0.36 or 36/100ths. On the left side, we take 0.3 and we subtract 0.52, and we're left with negative 0.22x. And then we subtract the 0.24. We just carry that down. Now we need to move this constant, this subtraction of 0.24, to the right side. So we're going to add 0.24. You always use your inverse operation to move it. On the left side, 0.24 minus 0.24 equals 0, so we're left with negative 0.22x. And on the right side, we take 0.36, and we add 0.24, and you get a total of 0.6 or 6/10. The final step is to get rid of this negative 0.22. To do that, we use inverse operations. Division is the inverse operation of multiplication. On the left, we're left with 1x, and on the right, 0.6 divided by a negative 0.22 equals negative 2.72, repeating. So that should be your final answer. The next problem, the last problem in station 2, is number 5. And we're going to see first if we can collect like terms on the left side. And on the left side, you'll see that we can collect like terms. We have two terms that have an x for the variable with a power of 1. So they're like terms if they have the same variable with the same exponent. So we take 3.7, we add 9.3, and we get a total of 13x. Everything else I'm just going to copy down, making sure that I make the decimals nice and clear. And then on the right side, there's also like terms that we can collect. 7 plus 0.35 equals 7.35. On the left side, we have 13x minus 0.88. Now we're at the point where we can move the variables to one side and the constants to the other. So I'm going to label my sides. We could have done it the opposite way. We could have had the constants on the left and the variables on the right. But this time, we're going to move the variables with their coefficients to the left side using inverse operations. So the opposite of subtraction is addition. On the left side, negative 4x plus 4x equals 0, and we're left with 7.35. On the left side, 13x plus 4x gives you 17x. And I copy down on that side, minus 0.88. Now I need to move the negative 0.88 to the constant side using inverse operations. On the left side, negative 0.88 plus 0.88 equals 17x. On the right side, you take 7.35 and you add 0.88, and you get a total of 8.23. And then finally, the last step is to divide each side by 17 to get x alone. So x is equal to 8.23 divided by 17, which gives you 0.484, and I'm going to round when we get to the nearest 10,000th place. So I'll keep writing, and I don't need to write anymore because I said I was going to round to the nearest 10,000th place. So tenths, hundredths, thousands, 10,000ths. So x equals 0.4841. And I'm going to change that to approximately because it's not exactly, since we rounded. And that's all for station 2.